are going to start with Pearsons. And for Pearsons, you need two things. You need categories. So you need, the example here is sort of like this is your main example, maybe from statistics class in high school or college, right? I have a dice, assuming that it's not loaded, it should be due to chance alone. I should get an equal number of 1s, 2s, 3s, 4s, 5s, and 6s. And if I don't get that, then I need to ask more questions, right? Then as I think he was probably a really good gambler, my statistics teacher. He would be like, well, is my dice loaded? What's going on? What's happening? So that's sort of what we're getting at. And that's a really simplified example, because in Dragonfly, we're not flipping coins. That's the other example you always see. You might be doing genetics. This would be useful in genetics because you could have a Punnett square and you could be predicting across. But for this one, we really need to know, okay, here's my sample. Here's what I actually observed when I rolled the dice. And then we really need to have some sort of method for determining an expected value. And that's where that thinking really comes in. So with a die, if I'm rolling it 120 times and there are 6 sides, I would expect that if that die were perfectly weighted and chance went exactly as it should go, each side would show up 20 times. So we have to have some kind of logic of being able to calculate an expected value. Do you have any questions so far? Great. So we're going to take a look at this in regards to the data that I was using. So we're going to go ahead into the inferential statistics worksheet, and then you're going to click on the tab at the bottom that says chi-square. And we're basically going to run, it's kind of in 3 parts. We're going to run sort of down this worksheet together. So this is what we call Pearsons, or goodness of fit. And the question that I really wanted to ask was basically like, because we all start with our research question, right? And sort of my broad topic was, are there people of color participating in conservation initiatives? Which I would say many of us know by just anecdotal evidence as leaders in that field, that can be a real challenge for some of our organizations. And so I was really asking that question again to say like, well, what can we do? So I had a group I was working with, Lights Out DC, and I sent surveys to all of their participants. And it was just a demographic survey. So there were no Likert scale questions or anything like that. It was just, here's what the census asks. Here's what I'm asking you. Because to get my expected value, I really needed to be able to look at the census to determine how many people I would expect of my 15 volunteers to sort of come out and represent the Washington, DC population. So that's sort of the table I have set up here. What I know going in is that here are my survey responses under this observed category. So you can see I had 15 people take the survey, 14 of them identified themselves as white, 1 person identified themselves as Hispanic or Latino. So that's what I observed in my sample. And I need to figure out, is that significantly different than the population of Washington, DC? So now here's where I have to do the calculating. So I know that I want my observed and my expected to match, because I'm saying that, and when I say match, I mean match in number. When I'm saying, okay, if I have 15 volunteers in front of me, how many of them, if they represented DC perfectly, should be white or black or American Indian or anything else? So what happens here is pretty simple. It's just a matter of recognizing this is what has to happen. We are just going to do equals. And so I knew from the census data that 34.8% of the population of DC was white. So this is just divided by 100 because it's easier for my math. I'm going to do that proportion of the population times my number of volunteers. Oops, I did it wrong. Equals. And then you're going to do shift 8 and then the number of volunteers. And so what that says is if my sample was accurately representative of the Washington, DC population, I should expect about 5 volunteers to be white. In my sample, 14 were white. So already I'm kind of like, well, this is maybe going to be different, right? And so we're going to do that all the way down for each one, which I should be able to just drag it down. maybe. Yeah, and you can see it. I know that it worked correctly because all of those places where I had 0, it remained 0. So just a good check from that.
I think, Katie, do you want it to be, sorry, do you want it to be B5 times 15 in that first?
Oh, yes, you're correct. Thank you.
Yep.
Appreciate it. Let's do that again. So I actually want it to be equals the total population, not 14, but the total population. So times the total, which is down here. There we go. Didn't change much, but only because of my survey data.
And now it gets confused because it's trying to drag. So like the first one's dragging 14 divided by 15. The next one's trying to drag 0 divided by. So I think if you just type in 15, if you want it to really, instead of using a cell.
Yep.
Yep.
Let's do that. Mine's all in Excel, which is like different. And so this goes back to like how you set up your spreadsheets, right? So yeah, it is kind of different depending on what you use. And chi-square does sort of require you to set up these tables. So we're going to do that. This times 15. No. Oh, guys, come on. Okay. Times 15. There we go. All right, now I should be able to drag it because it has a value and not a cell. You can also do it by hand all the way down. We know that these are going to be 0. And that's like the importance of like checking your data, right? Is like making sure, does that make sense? Because it doesn't make sense. Actually, those were right. Sorry. Okay. So then I should be able to say like, okay, if my sample represented Washington, D.C., about 5 people should identify as white, about 8 people should identify as Black. I may have 1 to 0 volunteers who identify as American Indian, and so on and so forth. So looking at my data, obviously, this is going to be something that is very far off. My observed are very far off from my expected, but we still need to go through the process of putting in the p-value. So to do that, one thing that we're going to calculate for the chi-square statistic is the degrees of freedom, which for other tests is really, really difficult to calculate. It's sort of something that's often assumed or given to you. But for chi-square, we're just going to take the number of categories we have. So we had 1, 2, 3, 4, 5, 6, 7 categories. So our degrees of freedom are going to be 6. And like Kevin was talking about how to report a statistic, degrees of freedom is something you would report to say like, hey, I had 6 categories. So that's something that's not going to be important to our calculation, but it is going to be important if we write a manuscript about it. And then for the good news, extra good news for you, is that you don't have to calculate a chi-square like this by hand. It will actually do it for you now, which was not true 5 years ago. So we're just going to go here, and we are going to type in equals chi, and you'll see you get a bunch of different options. And at first, they look very scary. But in fact, they're the same thing over again. So Google Sheets has its own code, and Excel has its own code. So it's giving you the options as if you were in either one. So what we're really between is the chi-dist and the chi-test. And we said this was Pearsons because we're looking at a sample within a population. So we're going to choose chi-test. And then we're going to highlight our observed array. And then we're going to highlight our expected array. Oh, come on. Sorry, guys. I swear I did this before. It worked fine. All right, let's try this one more time. Our observed and our expected. There we go. So you can see my p-value is 0.0006477. So obviously that was significant, and just doing that sensibility check, my observed values were really different from my expected values. We're expecting that to be significant. So from this, I could say, okay, our volunteer base at Lights Out DC does not represent the larger population of Washington, DC. And then we were able to move forward and have some discussions about that. Why is that? Are we in a particular part of DC? Are there areas we're not servicing? Is it an issue of people of color? They're going out very early in the morning to collect bird strikes. That's what Lights Out DC does. So is this more of a safety issue? What can we do to include more parts of DC and to make people feel more comfortable being part of this organization? So that's sort of kind of all the way through, going from question to categories to calculations to action.